My name's Ken Toler. I'm the head of security at Filecoin Foundation. Filecoin Foundation is helping with the Filecoin ecosystem, and the main thing that we're doing is helping to store humanity's data. And we do that in, through the blockchain ecosystems and things like that. My role is to help facilitate security for that ecosystem through security programs and organizations that we establish across the board with all of these different organizations and teams to help fortify Filecoin as an ecosystem and as in crypto. In this space, for something that is always live and for something that is made from distributed teams, reliability is extremely important. It's one of the things that we strive for. When you're talking about a decentralized ecosystem like this, the power of that and reliability is being something that is not held by one central organization, but is made up of the participation of its members and of the folks that support Filecoin as an ecosystem and as a storage provider. So. Reliability for something like that can be very difficult to achieve and is really reliant on the participants of that ecosystem. Let's say that there's a bug inside of the system. Every single person that updates that particular system is going to have that bug, which means that there is a global product or system that could be affected by that. So it's important for us to discover those early. The other thing that you have to think about here is that there's no one central component of these systems. A lot of this is made up of open source products or core contributors and libraries that are, these folks come from different countries, different places. Sometimes they're volunteering their time. It's important for us to keep an eye on what is going into code so that those types of outages don't happen. If we experience something like a chain halt, that downtime is detrimental to the entire system. And so making sure that we're resilient and being able to test for that, and not only test for it within the organization, but also with all of these different teams, becomes a real challenge when there's no unifying authority over that. And the goal is to have no real unifying authority, but that the participants are the ones authorizing this type of behavior. So a lot of that is built into the system, right? I mean, the cryptographic proofs inside of something like the Filecoin ecosystem help to provide some of that reliability, but also looking for ways like using antithesis that help us with testing. Being able to test beyond what you would see in a production environment is very important for us because we can't necessarily predict the behavior on the network, and we're reliant on those cryptographic proofs and the incentives that the ecosystem provides in order for folks to use it appropriately. So the interesting thing is that the way that software is tested across different groups can be different. So Filecoin Foundation doesn't manage a testing platform. There are a very limited number of engineers at Filecoin Foundation itself. What our role is, especially on the security side, is to interact with other folks inside of the ecosystem, and they may be testing their individual components in different ways. So when you talk about something like test coverage in an enterprise organization, you can measure this test coverage across a particular product or organization. But there may be other organizations, whether they're open source or not, that are testing their test coverage or establishing their test coverage in a different way. So there's no real centralized way to view all of the test coverage across all of the components. You are reliant on these different components, these different teams. So what our goal is to try to establish that, right, and to make sure that we are pulling in these core components into some unified architecture so that we can test them independently and provide another lens for these teams to use in addition to their own test coverage. Honestly, not much has changed for those development teams other than helping to contribute to the assertions that are inside of Antithesis. The main thing for us is we want to be as transparent to those groups as possible and provide them with these tools. So it's almost voluntary for them to use it. And we've seen that with some of these teams, they're very attracted to using it, and with other teams, they want to stick to their own testing pipelines. And the hope is that over time, it becomes so valuable for them to write these assertions that that is where they would shift their testing. And that's what's interesting about it, is because it doesn't really fit into their day-to-day as much as it does into the folks that we're working with at Antithesis and those teams themselves. So the goal is to be as transparent as possible so that teams don't feel like we're adding load to their day-to-day testing. So if they have a particular way that they want to test their software, they can do that, and that this is another option for them to do that. We hope that over time, this becomes the most valuable way to test the software and to provide as much insight into that. But what has changed for us is that we operate a bug bounty program. And one of our goals is to make sure that we're discovering issues before they get to a point where somebody is submitting a bug for a large bounty. We will operate a bug bounty for as long as we absolutely need to, and that is a very important part of our security program and of the Web3 security programs in general. But the nice thing is that if we're able to discover these beforehand, obviously we don't have to shell out any additional funds. So it's always good to find these things early. So it's allowed us to find bugs much earlier in the process, and that just helps us both financially, and it helps us in a way to make sure that we know that those bugs never made it to production. We found a few bugs. I think right now the biggest challenge for us in Antithesis is to figure out how to take all of these components and make them operate together in a simulation when you're talking about something as global and decentralized and distributed as crypto ecosystem or a blockchain or something like that, because you're trying to take something that is made up of thousands, maybe millions of nodes and reduce it to something that we can actually test within. And what I'll say is that we've been successful in finding issues that, had they made it to production, would have been catastrophic. We've been able to resolve those. We constantly people talk about shifting left, they talk about getting earlier in the SDLC. This is a common theme. And you'll see in the industry, we have trouble getting there. And this is something that you can do that has very tangible results to be able to see how you've made that shift. You can actually see, the proof in the pudding that there is a result that comes from testing this early, and it isn't after the product is deployed. I think when you talk about shifting left, this is one of the products or one of the tools that you can use that will actually help you do that. Probably 5 or 6 years ago, we used to talk about, does a security engineer need to know how to code? And I think that it's very clear that today they have to have some familiarity with code. And one of the challenges we've always had is, what does it mean to write a security unit test, or what does it mean to write a security user story? This provides a platform or a way for security engineers to contribute these types of tests to the development pipeline without affecting engineers. And there's two things that this really helps with. One is it depends on where you go, but there can be an adversarial relationship between security teams and engineering teams. But if security is enabled to provide or enable an engineering team, it makes it less adversarial, because now they're actually contributing to the code base in a meaningful way, as opposed to telling the engineers what's wrong with their code. If you can look at this as both a testing platform or autonomous testing platform, and as a way to test for security, I think that it will help to enhance and solidify the relationship between the security engineers and the application engineers, and it will make it so that security becomes an enabler to software development as opposed to a blocker. The Antithesis team is one of the biggest helps to our success in being able to deploy the product. I think one thing that is amazing is how technically competent the engineering team is, and how technically competent the Antithesis support team is, and how willing they are to take feedback and be able to say, or adjust with us in terms of how we want to deploy this and how we want to get it into the hands of our engineers and into the hands of those teams. Once you've received that first result, you'll know that you're finding unknown issues, and depending on your business, that can be an invaluable thing, especially given the gravity of what some of these issues could result in. When you find that first bug that would be a higher critical severity issue reported by a security researcher, that's the switch, because that's a payout that you're not making to a researcher, which, sorry for the researcher, but that means that we found it earlier, months earlier, a year earlier, who knows, but we found it, and we can say that we found it before someone else did. And from a security perspective, how often can you say, I found this before someone else did?